Hello, I'm Christopher Parham. You may know me as IceCube57 on the Analyst forum. I'm going to do a short podcast type thing to where I go over various topics. It's going to start off with me for now, and then I'll get other forum elite members to either chime in, debate, or discuss more things on certain topics. The topic I wanted to go over today is the thermal throttling of the psychoanalyst V3 and how it helps you sustain more continuous duty out of a motor. So a few years ago, the psychoanalyst V3 came out, and one of the things that it offered was a temp sensor input, and you can use either a thermistor or 10K thermistor type device that has like a specific reading at a certain temperature. It has like a specific resistance, and then of course as the temperature increases or decreases, the resistance of this device changes, and then you can translate this to an actual reading on a psychoanalyst. So this is really nice when it comes to monitoring your motor temperature, and so you can either manually control the throttle to see how aggressive you can ride and keep it under a certain temperature. But a lot of times, like, we have a lot of new people, and the first thing they want to do is, get a 48 volt kit. And again, these motors are supposed to be ran at 48 volts, and they've been tested at 48 volts. So they can pretty much run 48 volts and a certain amount of amperage continuous. But the first thing that people do is try to hot rod these motors for more speed and more torque and everything. And so with this extra power comes extra heat and everything associated with it. So normally the temperature in the motor increases to a certain temperature, and then it levels off. That is, if you're running the motor in the parameters that it's supposed to be. So if you have a 48 volt motor that's been rated at 1500 watts, then pretty much it's supposed to run 48 volts and then pretty much draw somewhere around 1500 watts to maintain its speed. Yes, you may peak more power into it. Like I said, most of the time these controllers have 1500, like 3000 watts. It would be like a 48 volt. I don't know the math right now. I'm about to do the math. So let's say 3000 watts is the peak power of the controller, and we divide that by 48 volts. So it can take about 60 amps peak that are the controller. And this is not, trust me, there's no controller on the market that's in the public sector that, like, for liability purposes, you'll never see a 62 amp controller. But again, the first thing that people do when they get the taste of the e-bike bug is buy a larger controller. So, this is assuming that somebody bought a LAN 12 FET controller and 12 FET or 18 FET controller, and wanted more power by giving it more amps. Same voltage but more amps. So that's 3000 watts that the controller will put into the motor. The motor could take that continuously depending on the terrain. It can probably draw that 3000 watts continuously. But what is more it's more continuous duty is the 1500 watts that it's rated for, meaning that when the motor is ramping up, it's pulling a lot of amps, and so that's normally where you get your peak wattage from. But as it gets to top speed, the amperage is supposed to, the phase current or the amperage is supposed to taper down to something that's a little bit more continuous. And so when these 48 volt motors get up to top speed, if you pick the right motor, it's supposed to pretty much draw somewhere around 1500 watts, which you should be able to sustain that continuously. Or or your riding style should average pretty much about 1500 watts, meaning like it may be stop and go, but you know, your average draw over a certain period of time is about 1500 watts, and it will basically have like an equilibrium of a certain temperature where you're not hurting the windings, you're not um, hurting the Hall sensors and stuff like that. Hall sensors, they typically pop around 160 or 170 C. It just depends on if it's good quality Hall sensors or if it's crappy Hall sensors, but normally somewhere around 150, 160, 170, somewhere around there, the Hall sensors will fail. The winding insulation, you know, there's different classes of winding insulation, but most hub motors are typically the enamel or magnet wire is pretty much almost in the same category. It's about 150 to 180 C. Yeah, you can push these motors a lot harder, but the enamel starts to degrade at around those temperatures. So yeah, you can push a hub motor up to 200 C, and sometimes the Hall sensors can take that temporarily, but you know, in controlled conditions, or the white data sheet specification says, you know, the Hall sensors and the windings can take this certain temperature continuously without degradation. Anything past that, it will start to degrade and it will start losing its properties or start malfunctioning. So going back to the 1500 watt limit, as the motor ramps up, the current tapers off, and you know, at top speed, it should be able to maintain about 1500 watts to maintain the top speed of that motor, which is fine. But when you start increasing the voltage, this changes the power band. And basically what happens is, like, I had a golden motor and I ran 66 volts and 60 amps. And so as it approached top speed, which was around 38 miles an hour or something with me on it, it's very close to its no load speed, which was like 42 miles an hour. So when you look at the efficiency curve and everything, it's getting pretty much most of its efficiency because the motor is able to reach its peak top speed. But when you start increasing the voltage, this changes that RPM curve, and so now, you know, due to wind resistance, you know, and a whole bunch of other factors that come into play that slow you down as you try to gain speed and break a certain speed limit, the losses become exponential. So the amount of power that you put in is not going to translate to a specific set of increasing speed. So if I had my motor that was going 66 volts and it does, motor at 66 volts and it does 42 miles per hour unloaded, I'm getting 38 unloaded. I'm running that pretty efficient. The current is tapering off and it's running about 1500 watts, 2000 watts at top speed. When you increase the voltage, that no load speed goes up to something else. So let's say the no load speed went from 42 up to 55 miles an hour. Or let's do 60 miles an hour, and these are not exact figures, but this is just to give you an idea of what happens. So the new no load speed is 60 miles an hour, but the actual loaded speed only translated to 45 miles an hour. So there is a bigger gap between the unloaded speed and the loaded speed, meaning the motor can't reach its full speed, and so this hurts the efficiency curve. So the motor is less efficient, and since it's not able to reach its no load speed, it's drawing more current, and it's not necessarily drawing more current, it's just sustaining a higher current trying to reach a top speed that it'll never be able to reach. So what happens is the motor, instead of it tapering off to like 1500 watts or 2000 watts continuous that it's able to shed the heat for, is peaking at 3000 watts. And so over time, this motor is getting saturated and it's getting hotter, and and the resistance and the windings are going up, and then the acceleration starts to feel kind of spongy, and you're basically saturating this motor and getting it hot to the extent where it doesn't perform like it should, because it can't get rid of this heat that's it can't get rid of this waste heat that's being wasted. So instead of a motor being 80-85% efficient, when it's able to reach its no load speed, is down lower to 50 or 60. So it's wasting all this power. And so at the same time, you have controllers that have a certain thermal capability. Like, we have controllers that are rated at 1,000 watts, but it can put out 2,000, or yada yada yada. So the same thing that happens with the motors happens with the controller. These controllers are meant to peak up at a certain wattage, but it's expecting the motor that's attached to taper off in current. And once it tapers off in current, the controller runs a little bit more efficiently, because it's not having to current limit. When it's current limited, when the controller is current limiting for the motor, is running really, really inefficient. So it tends to build up a lot of heat in the controller. But when the motor is allowed to reach the top speed, the current decays naturally, and the controller can stop current limiting, because the motor is doing it itself. It's generating back EMF. When you spin a wheel, it generates its own voltage, and the controller is fighting that. So in a way, when you're accelerating, the controller is winning and dumping all this power, and it's like, hey, I'm the strong guy, you're going to take this power. But once it gets up to top speed, the motor starts fighting back and generating its own power. And basically, when you reach top speed, the power going in is almost the same amount of power that's being generated from the motor, so it's like a stalemate. So like I said, that's why the current naturally decays. So it's putting all of this power into the motor, but as it speeds up, the motor starts fighting back, and there's like, a reverse current or reverse voltage. However you want to look at it, it's really hard to explain, but there's this reverse power coming back, and so that caused the current to drop off. And so, you go from a motor controller putting out 60 amps to a motor controller putting out 20 amps. So when you go up in voltage and the motor is not allowed to reach its peak speed, you still have a controller that's putting out 60 amps. And it can't do that continuous, and so you end up having a controller that gets hot, and sometimes they eventually get to a point where they get critical, and the MOSFETs may blow in it, because it can't handle the thermal load that's presented. The controller can shed that heat away. So that's one of the reasons why, if you don't choose the correct winding for your terrain and run the correct voltage on that winding, you can create a situation where you have the motor, it'll get super saturated and hot, because the controller is trying to feed it power, and the motor can't get up to top speed, so it's just asking, give me more power, give me more power, I think I can do it, I think I can do it, and it still can't pull it off. And so here it is, wasting all this power, and then you might eventually fry the motor, or fry something in the motor, or the controller may fail because it can't keep sustaining the power to this motor. There are certain scenarios where certain windings will come into play, like if you're in a totally flat region, like totally flat, like Oklahoma or something like that, you can get a high-speed wind and run it at 48 volts or 60 volts, or even higher voltages. And you can probably get away with it because the motor should be allowed to get near its top load speed. But if you live somewhere like freaking Colorado or Georgia or someplace where there's a hill around every corner, here it is, yeah, you may be able to get up the hill, but it's taking so much power and wasting, and since the motor is not running in its efficient range, it's wasting so much power and creating so much heat that it ends up overheating. So typically in hilly terrains, you want to run a slower motor that can reach its top speed a lot quicker. And they call these torque lines. You know, they have a lot of torque, but that's not necessarily the case. I'm not going to get into the myths on, you know, this motor and this motor, depending on how much power you put in them, they equal the same amount of torque. I'm not going to get into that. We're going to touch on that later. But typically you want to run a slower wind motor and a higher voltage when you live in a hilly area, because it can reach its no load speed a lot better than a fast wind motor that you're feeding a lot of voltage that's not able to get anywhere near its top speed. But going back to the cycle analyst and how that interrupts things, the cycle analyst V3 has the input for the temp sensor, so the temp sensor is feeding information. And if you have your cycle analyst hooked up correctly, your cycle analyst is sitting in between your throttle and the controller. So it's getting fed all this information, everything from information from the Hall sensors to let it know what speed it's doing, information from the shunt letting it know how much current is flowing in the controller, information from the temp sensor letting it know how hot it is seeing the throttle voltage. You program your throttle range into it, so there's a whole bunch of things that it's looking at it, and it's interpreting its data, and it's not exporting, but it's putting out a certain voltage to the controller. So how the thermal throttling works is there's a temperature range that you want your motor to stay in. So basically, when it's at not nominal temperature, but whenever it's at ambient temperature, it's pretty much allowing full power, you know. So you can get all 1,000, 3,000, 5,000 watts, whatever the limit of your controller is allowed to send that power to the motor. So when the temperature starts rising, it's giving you like, hey, you know, we're at 30 C now, we're at 50 C after I went around the block, and you know, and as it gradually goes up, it's still allowing you full power. The first threshold is the threshold where it starts limiting power. So I think by default it may be set around, I don't know, 80 or 90 C by default, and basically at that point it starts progressively limiting the power. So if you have 5,000 watts and you hit that threshold, it starts taking a little bit power away. So instead of you having a 5,000 watt controller, it starts pulling it back to 4,500. And as it keeps going up, like it's at 100 C, so we're at 4,000 watts, and we're at 105 C, it's at 3,500 watts, and it progressively starts pulling power away. And what it's trying to do is pull the power away so that it can maintain a certain temperature that you program into it. So, you know, if, let's say on my bike, I have mine programmed between 90 C, and the motor shouldn't get any higher than 140 C. So at 90 C, it's just starting to limit. I'm still seeing almost full power, but it's starting to pull back a little bit. At 140 C, it's totally pulled back the power. So, you know, you're barely getting 250, 500 watts when it gets up to 140 C. And so from what I noticed when I start riding, once you start getting into the throttle limiting zone, it hovers kind of right in the middle. So between 90 C and 140 C, you start hanging around 120, about 120, 115, 120 C is what the motor would start hanging around. And basically that's whatever wattage that you see during this period when it's in between the peak temperature and the initial temperature and the peak temperature, whatever number you see the motor hovering at, is what you see, is the continuous wattage that that motor can take. So right now I have the MXUS 3000 watt motor, and I'm seeing, and it's vented. I drilled holes in the cover, so it's vented. So my limit is between 90 and 140, and at about 120, I'm seeing about 3,000 watts roughly. What the motor is able to maintain without going to a critical point where it's overheating and I start having super degraded performance. So I do have a controller that can put out 5,500, 6,000 watts, but once it gets into that limiting phase and the psychoanalyst is trying to maintain a certain temperature, and not exceed a certain temperature, it hangs around about 115, 120, sometimes even 125. And I'm seeing anywhere between 2,500 to 3,500 watts, which is the continuous rating for that motor. And again, this motor, it was pretty much dynoed at 48 volts, so I am running a slightly overclocked motor. So at 48 volts, 48 volts and 60 amps, it should be able to run that all day. Some people are running 60 volts and 60 amps and running that all day. I'm running a little bit more and a little bit more voltage and a little bit more amperage, and that's how we can maintain a continuous duty in the motor. If you didn't have a psychoanalyst V3 and you weren't using the temp sensor or whatever, basically you will be feeding that motor so much power that it can't get rid of the waste heat that's being created, and you'll just burn out the motor or burn out the controller if you don't even do the basic things, like, you know, at the very least one should be getting off, like if you're riding your motor very hard, one should be getting off the motor, getting off the bike every 5 or so miles and just checking the motor cover. And if you can hold your hand on the cover more than 10 seconds, then you're okay. But if you can't, you got that motor way too hot, and then once you get that motor hot, you start damaging the windings. You possibly could lose the hall sensors. You start demagnetizing the magnets, and it just creates a runaway scenario that you're causing damage to the motor, when you could have spent the $20 extra dollars and got, instead of getting a psychoanalyst V2.3, or you could have got a V3 and then spending an extra 30 minutes, hour, 2 hours to take apart that motor and install that temp sensor into it, and getting and feeding the psychoanalyst the reading that it needs to intervene when you're riding. And like I said, when it's intervening, you will notice a loss in power, but you'll be surprised at how much power is still available even when it intervenes. And it's good to know that even if you are on the extreme end of the temperature range, it still will allow you to limp home. There are other devices like, sometimes like Kelly controllers, if they get hot, they would just totally cut all power. There's temp switches that you can put inside the motor that, for a while I used to use something that interrupted the Hall signal. So once that Hall sensor was deactivated, the motor started running really, really crappy. And so once it cooled down, it restored the connection and allowed the Halls to operate properly, and you can continue riding. And then I did another reinvention of that by using the same temp switch, and I basically ran a signal from the switch inside the motor to the 3-speed switch. So when it was open, the controller would run at normal speed with no restriction, but when it got hot, I basically put it in a limp home mode at 15-20 miles per hour, where the controller was limited to 15-20 miles an hour, where I could still move, but it allowed the motor to cool off, and it still allowed me to keep going to my destination. So, there's been an evolution of switches and temp sensors. People use barbecue sensors that are used on barbecue grills, and the reason why they use temp sensors for barbecue grills is because it can read a much higher temperature than a regular sensor that is for household weather that normally peak at 140 or 160 degrees. The barbecue sensors can go up to like 200-300 C and give you 200 and 300 C or 600 degrees or whatever. I don't know the direct translation, but they can read much higher. But it just creates a much more bulkier handlebar setup. Some people even used Turnigy has this temp sensor thing that you could wire into your motor, and it will. You can feed it, like you can feed power to it and wire it inside the motor and put the temp sensor in the winding, and it will just let out this screech once it reaches a certain temperature, and then as it cools off, the alarm will cut off. But this kind of makes it look kind of weird when you're riding in a park and you got something that's literally screeching out at you, and it doesn't cut off until your motor cools off. And typically a motor can take, if it's vented, it can be as little as 2 or 3 minutes for it to drop down to a respectable temperature. But if it's not vented, sometimes that traps the heat, and it can just sit there and basically, like an easy bake oven. You'll probably make muffins in a motor, in a sealed motor. It's very, very hot, so it takes even longer, 10 to 15 minutes, to get it to drop down to a respectable temperature. And it's like, just because it even drops off a little temperature, it may drop 20 degrees. If you still continue riding, if you hop back on it a mile, a minute or two later or a mile or two down the road, you could be back at the same temperature. So why put yourself in a situation where you have to keep stopping when, if you use the Analyst V3, it intervenes before it even gets to a critical point. And yeah, you have a sudden loss of power, but not a sudden loss, but you notice the power dropping off, but it's not leaving you dead in the water. And I wouldn't say my testimony for the Analyst V3, sorry for the break in the other video or other audio clip, but I was going on about my testimony with the V3 Analyst. And so I started using the V3 Analyst with the Magic Pi 2 motor, and this is not a heavy motor, but its open design and large diameter helped it develop a lot of torque. And when I vented it, it's such a large canvas that when I vented it, I put a ring of holes on the outside and also put some on the inside. And so this helped it shed heat really, really well. And so this testimony is two-part, and it's more on, I believe that 18S is the magic voltage. And from my experience over the past years, I've been doing e-bikes since 2008. So my experience with voltage and motors and everything is that 18S, which is 66 volt nominal and 75 volts fully charged, that is at that perfect voltage where you can hot ride a motor and get very, very decent performance out of it. Have it be continuous duty to where you can get this same performance without it waning too much, and you don't have to really worry about cooking a motor or anything too often, as long as you're riding it in the appropriate terrain. So I've had motors in the past, everything from the 9C motors to geared BMC motors to the Magic Pi. I currently have the MXUS 3000 watt motor, and currently that's the best motor that I've had so far, due to its mass and, the amount of power that it can develop and everything. So in this, going back to this Magic Pi motor, I was at 66 volts and on a 12 FET controller, and I was doing about 65 to 70 amps, and it was peaking up to like 80. And this was a 3077 MOSFET controller, so it was a 12 FET 3077 MOSFET controller. The maximum voltage that this controller could take is 75 volts, so it could barely hold an 18S pack. But this MOSFET is a very efficient MOSFET. It doesn't create a lot of heat because of its lower on resistance. And also, the motor is a quote-unquote torque winding, or a slower winding, which means it's a lower kV. kV means basically how many revolutions it does per volt. So I think it's like around 9 kV. So every volt that you have, the motor will have 9 RPMs. So it's a low kV motor. And so what this allowed me to do is have a motor that, if I was on a flat straightaway, it could get up to top speed, and the top speed on 18S was about 38 miles an hour. That's the top loaded speed, and the unloaded speed was 42, 43. So I'm really close to its top speed, and it's at a certain point where it's just barely sipping power. It's already within its continuous duty range of about 2,000 watts to maintain that high 30 mile per hour. But the V3 took it, the V3 cycle analyst with the thermal throttling took it a step further. The thing is I'm in Georgia, and it's not flat by any means. There's a hill around every corner and whatnot, either a hill or a slight grade or whatever. And so basically this motor can't deal with that on a continuous basis. So, even though it does 2,000 watts in a flat, you get it on a slight incline, it's back to pulling power, trying to get up to top speed. And so if you're pulling 3,000 watts or 4,000 watts trying to accelerate up this incline or maintain top speed up this incline, you're eventually going to get the motor hot. Even if it is vented, it's still going to get to a critical point where it does get hot. So the V3 cycle analyst comes in by throttling that power. And so again, just as I set those temperature ranges between 90 C and 140 C, it was hovering right around 120 C. And whenever I used to ride with a friend, and he rides a recumbent, and when I say he hauled ass on the recumbent, it was hard to keep up with him. And so before I had the V3 cycle analyst, I was trying to keep up with them. I was, overheating the motor. You were smelling the windings. You might saw a whiff of smoke every now and then as the enamel or varnish burnt off the wire and everything. And as soon as I got the V3 cycle analyst and installed the temp sensor, that totally changed. I was able to ride with this person to the point where, even though he was trying to drop me, like I said, this is a strong rider. He can maintain high 20s, low 30s on his recumbent. And when I say he was trying to lose me, and he couldn't, and then he got to the point where I'm just tired, because he knew before, when I had the V3, before I had the V3 and the temp sensor, he knew that all I had to do is take him through a certain route, or get him in some stop and go traffic or whatever, and he would say, oh, my motor's overheating or whatever. And after I got it, I was just keeping up with him. We rode 20 some odd miles one night, and I was able to keep up with him to the point where he's like, man, I'm tired. I'm going home, man. It seems like you got a pretty solid bike built. And so, this is on a smaller motor that doesn't have the same mass as the like a Crow motor or whatever, but is able to maintain that continuous duty. And it's all due to me picking the right winding for the terrain that I'm in, picking a voltage where you get decent performance, but it's not oversaturating the motor. If I would have run 24S on this motor, it would definitely be oversaturated that thermal throttling will be kicking in, and it will be kicking in really aggressive. So that's why I believe 18S, maybe even 20S, is a good point to be at with most motors, because it's really hard to super saturate those motors to where they're unusable and you're seeing smoke and stuff. It's really hard to get the motors hot at those voltages and even maintain a respectable amp. Anywhere between 45 and 65 amps, it'll give you enough peak power to where you can say that I have a truly fast bike, and off the line you'll be cars and everything, but once you taper off to a cruising speed, it's able to maintain that speed without very little waste heat, and it's in this butter zone where it wants to be. And like I said, the low turn to mid turn motors are best for hot rodding. There are some people that are on a budget, and they'll get a high speed motor, like I said, a high speed motor in 48 volts. There's some of them that can do 35 miles an hour on 48 volts, almost 40. But then again, like I said, they get that taste for speed, and they want to throw more voltage at it, and that's not good. You should have had a lower speed motor and throw it more voltage to where it's more efficient and it can reach its top speed a lot easier, and it won't be sucking down so many amps and everything. Like a low turn motor, you can grow into that motor, and just all you have to really do is just keep bumping up the voltage until you're satisfied with the speed, and it'll be 9 times out of 10 it'll be more efficient than a high turn motor. And so that's one story. I mean, like I said, that's a twofold thing. Like I said, the voltage plays a big part in keeping a motor under continuous duty, and the cycle analyst was just the icing on the cake that even on this current motor, there, I rode in downtown Atlanta after a critical mass ride, and it was like maybe 10 miles back to my car, and it was a pretty straight shot, but we're in 25, 35, 45 miles per hour zones, and I was beating people off the line and riding 35, 40, sometimes 40 miles per hour, and keeping pace with traffic. And at the same time that all this is going on, the cycle analyst is limiting me in some form or fashion during that entire ride, whether it be a little or be a lot. There was times where I would, be on a straightaway and it was level, and actually you saw the temperature peak and fall down, and actually when it's falling down, that's just giving me more power to keep riding, and my speed would increase. And it's like, as long as I was moving, and since my motor is winning, as long as I was moving, it reached a temperature equilibrium. And if I got to a point where I hit a few traffic lights, even though I was in limiting, I still had plenty of power to even take off the be a jackrabbit start and get off the line and get 3 or 4 car lengths in between these cars and keep moving without it impacting my performance. And I know for a fact that if I didn't have the V3 cycle analyst and the thermal throttling, that I would definitely, again, would be stopping somewhere on the side of the road, because even though you see temperature, I've had motors where I've had a temp sensor installed and you're sitting there looking at the temperature, but it's hard to pull the power back yourself. Trying to not use as much throttle, so you're not using as much power. You're losing a lot of speed, and you're not just really getting the same type of performance that you expect from trying to control things yourself. But once that V3 cycle analyst kicks in and the thermal throttling, you don't have to think about that. You know that the cycle analyst is doing its own calculation and giving you a proportional amount of power, so you can maintain this this quality ride. This riding style. You can maintain it, definitely a lot longer to indefinitely. But again, it's not going to save you from wrong motor choices. Again, like I said, if you're in Colorado or Montana or whatever, some mountainous terrain, and you pick a high-speed motor. Yeah, you want to go 50 miles per hour, but you got to be a little bit realistic. Just because you have this motor and you're running in at 72 volts and you run it at 72 volts, and yeah, it's getting up to 55, 60 miles per hour, and then you go to climb a hill. Yeah, you're climbing up that hill pretty fast, but you're wasting a ton of power to where you could actually be using that same power and actually getting more kinetic energy or kinetic force, or you can get more motion for the amount of power that you're putting in by being in the correct winding and shifting your voltage slightly, and or even shifting to a different style bike. I was actually surprised I had the BBS02, the Bafane 8-Fun mid-drive, and I was surprised at how much 1500 watts or 1800 watts could do. I had it on the bike, and the hill that's on my street is peaks up to 15% grade. And I throw that thing in grading gear and it climbs it like a goat. But if I had a hub motor at the same wattage, it would stall out on the hill. So it's amazing to see, if you put your eggs in the right basket and buy the right things and stuff, that you can overcome certain obstacles that you can't otherwise, and not to say that high-speed winds can't climb hills or anything like that. Yeah, you can throw enough power in a high-speed wind to where that thing would just blow anything out of the water. But like I said, again, you'll waste so much power doing it, you'll saturate the motor a lot faster, and then you're going to find yourself on the side of the road, asking yourself what happened, and then I'm be the one on the forum trying to tell you, basically, I told you so, and you can make much wiser choices. I remember I was telling this guy that commented on one of my videos, he asked about the BBS02, and then he later told me that he ended up getting a 9C type motor, and then he was saying, oh, I'm going to upgrade the controller, like I'm a radio operator, so I know how to do, deal with tubes and transistors, and I know how to solder and everything. I'm going to upgrade this controller. The controller, I believe, was either a 6-FET or a 9-FET, and he was trying to hot rod a 9C style motor. And then he was like, I've seen people do 100 volts, 100 amps, and this, that, and the other, and I'm still thinking, I'm like, this guy is about to burn up this motor. And then he's like, well, here's a video link on this guy that did Pikes Peak, and he had a 9C motor, and, blah, 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 blah. And I'm like, he was able to get the performance out of that motor because he clearly thought out all the variables and everything. He ran 120 volts, 125 volts, and he had a 9C 10-turn motor. That's a slow fucking wind. And again, like I said, slower motors would tend to develop more torque. So, and again, like I said, that's a weird misconception. We'll touch on that later, but if you put them in the simulator, they do develop a hair bit more torque, but they're more efficient at delivering that torque, especially on the top end. You're going to have insane acceleration if you feed it enough power on the low end, and then when the motor tops out at its top speed, it's going to be sipping amps, and it'll be sipping amps much less than an 8-turn, 7-turn, or 6-turn motor. The 6-turn motor, yeah, it'll have higher speed, but it'll be poor at hill climbing because it'll saturate itself so quickly, and it'll be so inefficient. So it's like, again, I'm throwing numbers out here just to give you a better idea. So at 120 volts, 125 volts, this 10-turn 9C motor, let's say is 80 or 85% efficient. On the other end, if you got a 9x7 motor, you're talking about maybe 50 or 60% efficiency under the same wind, under the same voltage. If even that, it'll probably be much worse. And like I said, the 7-turn motor or 9x7 would be trying to go a lot faster, and you're going up Pikes Peak, which is nothing but a glorified mountain on, glorified hill mountain on steroids, or whatever, but it's a definitely proven ground for a lot of vehicles. And so he was able to steadily climb this hill on 125 volts on a 10-turn motor, because the top speed of that motor, when he got that motor up to speed, it was in such an efficient range that it wasn't wasting a lot of its power. He was doing like 2,500 watts, climbing Pikes Peak, but a motor under the same circumstances would have, but got to mention it was oil cooled too, so it was much better at shedding the heat. But seeing this guy thinking that, oh, I'm gonna get this motor that I got, I think he got it at a garage sale or something like that. Oh, I'm gonna get this motor, throw a ton of power at it, and then throw a upgrade this controller and get more voltage, and swap this out and swap that out. That's the mentality that I just hate seeing on the forum. You have somebody that clearly, they got the bug, and they clearly want to, go fast and everything, but you just see them going down this rabbit hole, and you know where it's going to end. And if they would have focused their energy on making the correct decisions, they would have a much better outcome, and it wouldn't have, because eventually he's going to smoke that motor, pop the controller, and probably end up getting another motor. And if you listen to us the second go around, he'll probably buy the correct motor, and maybe it will be a learning lesson. But we can eliminate most of this, most of these lessons, by if you just listen to some of the people on the forum that's been doing this for a few years. If you listen to us, and we're telling you what exactly is going to happen, and no matter how you try to rationalize it, it's going to happen. And so, like I said, typically people end up going that first route, and then and wasting money and burning up stuff or whatever, and then having to spend more money. If e-bikes is one of those things, if you don't have the correct budget to come at it, then what you need to do is do something that's on your level. Let this be your entry level bike, but do it correctly. And once you get a hang of that, your next few bikes will come a lot better. But don't go from like 0 to 60 on a piece of shit motor, and because you will end up having a lot more parts trail by trying to hot ride with your first bike than building a bike, learning from that, and then have your next bike be a better, as a testament to what you learned on the first one, but there are no parts lost. So I'm going to go ahead and end this now. And like I said, we're starting up a podcast. Me and 2 other guys on the Facebook forum. We're going to have like a 3-way to open discussion on certain topics. This was me, and like I said, this is not structured. It's just me kind of ranting, raving, trying to trailing on certain topics, and it's really hard for me to be on topic. But when we do this podcast, it'll definitely be a lot more structured. It's not going to be one opinion or one view. It's going to be 3 other people. We're going to get people in, some of the respected forum elite. We're going to get them in and interview them. We're probably going to interview a few vendors. And we're just going to keep it simple. It's not going to be like high production value or so uppity or whatever. We want more volume. We want more information. We want just a higher quantity of good information and a good opinion out there, so that you people, so that the community is well versed on their options, and how their options and their decisions influence their end build. And just being able to, instead of us having to type everything out and preach to you. We can just be like, go back to podcast number 7 and listen to what we have to say about motors and everything, and I want this to be one of those things that you jack into us, like, once, maybe twice a week. And this is going to be natural conversation for us. It's not going to be like so stiff, like Larry King gets interviewing people. It's going to be open discussion. There might be fighting, or I wouldn't say fighting, but it might end up being just a good poor public discussion where anybody can voice their opinions, chime in. We'll revisit topics. We'll answer more questions on certain topics. But we want this to be natural. We don't want this to feel like a chore or anything. Just as I'm talking to you, recording this, that's how the discussion is going to be. And if somebody objects to my view or opinion, they're going to have the chance to voice their opinion and possibly, prove me wrong. This is going to be information. There's going to be experience and everything. So instead of you having to sift through, you still need to go to the forum and refer to that as hard information. But we definitely could just eliminate a lot of the reading that's out there just by listening to us for an hour on the way to work, on the way to bed, background listening to when you're working or something like that. We just we want this to be valuable content, that we can pass, you can pass on to your friends or whatever. Mike Kiefer said he was making a book. And I'm like, people don't read anymore. I know I don't read. My wife has me trying to read books, self-help books, relationship books or whatever. I find the audio book every single time. So, and I can get through that book in an hour or two listening versus reading it over the course of, a few days. And so we're trying to get that information to you as quick as possible and get the point across and not talk over your head in such a manner to where it's not like we're talking down on you or anything, but we're just putting it in layman terms to where you can understand this is why we do this is why we do that, we want to do this, we want to do that, or spend your money on this or spend your money on that, or don't spend your money on this, or stay away from these people, and so we hope to educate a lot of new members, a lot of people that's getting into things, a lot of people that's been doing this a while, and they know of things, but they don't know why they happen or why we do this. They just know that that's how it is, and that's the way that it is, but don't know why. So we're going to put some of these things to the test. We're going to discuss some of these myths that are in electric bikes, and give you hardcore facts, and give you experience. It's like for the longest, you have vendors that tell you this, tell you that, and all of that, and give you all this white data sheet stuff on what their stuff can do. But we have people on here that Mike has tested so many products and everything. His specialty is mid drives. And you get Mike started on mid drives and he'll blow you away with so much information. We have Hoffman here that he's an upcoming e-bike vendor, very knowledgeable. And I think he's just almost like the middle ground. He's still being pruned and still gaining knowledge. But on the other hand, he reading some of his posts and everything, he's very knowledgeable. I'm one of those type of people. I'll tell you like it is and how I see it. And like I said, I've been doing this since '08-ish. Like I said, I had my first motor was a Wilderness Energy motor. It was a brush motor, and again, I see the people on the forum doing the same exact thing that I did. And first thing I did was it was running at 48 volts. What did I do? I ran it at 60 volts. And then what did I do after that? I ran it at 72 volts. And then I burnt the brushes up. and then I replaced the brushes, and then I burnt the controller up. Then I replaced the controller, and then it was just like people were like telling me, "God, stop, man, move on to brushless," and that's when I moved on to brushless, and you know, my motor after that was a golden motor. It was a 9C variant motor. It was like 48 volts and it did 35 miles an hour. And guess what I did? I put more voltage on it. And next thing you know, I was going 40. I put more voltage on it. Next thing you know, I'm going 45. Put more voltage on it. Next thing you know, I'm reaching 53 miles an hour. And of course, I burnt up that motor and fried controllers doing all of those upgrades and everything. So, I mean, so like there's people that have done all the stuff that these new people are trying to do, and we're like, no, no, don't do that. You know, don't waste your money on this, or don't waste your money on that, or if you want to put your money in anything, put it in this. At least you can upgrade from that, or whatever. So it's. Um, we definitely have people that have been through the ringer and have paid the price for new and upcoming people, and I won't say pay the road, but we have a brick in that road somewhere to where some of these people, some of these vendors that have built e-bikes, have taken our information and have elevated themselves, make things better, and produce products that we can appreciate. All the testing and all the R&D, all the blown controllers, and we know that, oh, we need to upgrade this or upgrade that, or don't use these MOSFETs and this, that, and the other. So you know we have living living databases of information that is hard for us to take all of this out every time that somebody comes across a problem or whatever. So we're just trying to leave an audio stepping stone where we can get this information to you. So instead of you spending hours trying to research minute topics, you're getting such a ton of information in minutes and able to grow, and we can respect you, respect these newbies. Instead of being angry at them, we can respect them for taking the initiative to listening to these upcoming podcasts and versing, and informing themselves um, on proper procedure and this, that, and the other. So that's what this is all about. This is the Pioneer podcast. I know I'm all over the place, but this is a little bit on what to expect from the three of us and any of our guests that we have. Like I said, we're going to be having an hour-long podcast, maybe a little bit longer. We're going to try to keep it at an hour, and if we want to continue the discussion, with one or two people dropping off, or just kind of, do a recap on everything that we discussed, it may be a little bit longer. But it definitely be something that you want to come back to. You want to have it playing in the background. You want to listen. You want to ask questions. That's the thing. It's one thing to be silent and be pissed off at us and not agreeing with our views. Trust me, if you have any objections to anything that we say or whatever, I would like to have you. We can do a one-on-one podcast so I can have your version of what you think I said or your correction on what I think I said. I think this just be one of those things that you feed us the information that you want, we feed you back, and if there needs to be something to make it whole, then I'll do a follow-up cast or mini cast to fill in the blanks or give another perspective. And like I said, I'm really excited about this, and I hope that this grows to be something that that we can be proud of as a community. And maybe it may go bigger. Maybe we'll upgrade to like a video podcast or something. But it's all up to the community, and what we put into it is what we get out of it. So thanks for listening, and looking forward to hearing feedback from you guys. Whether I know my voice isn't the sexiest thing ever, but you know, give me some feedback or what you like to see, and you know, or what you would like to hear, and I'll try to incorporate and make things a lot better. I know we're going to have some agendas, itineraries, and try to stay on topic and whatnot. So, you know, this is something big in its infancy, and it can only get better from here. So thanks for listening, and tune in next time whenever that is, and don't kill yourself. Stay on the road.